Hello, today I will try to solve classic permutation in a string. You given two string S1, S2, return true if S2 contains a permutation of S1 or false otherwise. In other words, return true if S1 permutation is in S2. So it's quite simple. So we have AB and here is BA. This is why we return true. So for that we need two things. We need to so it's definitely gonna be sliding window problem, solution, sliding window solution. And if we have two windows, when we have two strings, size of the window on second string will be length of the S1. So in this case, we're gonna have windows of size 2. And so let's call it L1 will be length of S1, right? Of size L1, len of S1. So, and then as we go forward, what we need to do, we have to keep keep counting characters. And for example, if we create C1 counter and iterate S2, remove. So first we add character to a counter on head of sliding window. Check if amount of, so we also need some kind of structure that is good for comparing two maps, two hash tables, right? As we did C1 counter, maybe we gonna do window counter. It's a bad name. Let's call it window counter as S2 from 0 to L1, right? So then we need to make sure somehow to make sure that our counter, window counter, equals C1 counter. So I would say how we're going to detect if window counter is equal C1. So one of possible ways to detect it, everyone we add in new character when when adding new character to window counter, we compare. So we can do it in first we count matches on C1 and window counter. Then every time we add new character to window counter, we compare amount of characters in C1, and if they match, we increase matches counter. So let's say we have some number like matches, right? And this will contain amount of uh, elements C1 and how to amount of so matches will be amount of I don't know how to calculate it yet. Also, I'm considering starting from window counter just default, or maybe just a dictionary. And matches may be 0. Then as I go in sliding window and add a new character to it, I will see if it matches with C1, and if it does, I increase amount of matches. If and when iterating, when adding new character window, we compare amount of characters in C1. If they match, increase matches counter. Then third step will be if matches equal L1, I will return true immediately. At the end, I will return false. Then, but this is not at the end. After that, I will remove character from end of the window. So it will be leaving character. As we move window forward, for example, here I will remove E. Right, and then move forward. And also, if I'm removing, I compare amount of character and increase matches count. Doing the same, right? We compare amount, we increase amount of counters, and doing the same. So this algorithm will allow us to go through element one by one and character one by one, and depending on how many matches we have in the window counter, we if we have exact match, we will return that inclusion is happening. All right. Yeah, so 10 minutes. Yeah, let's quickly try to implement and see, maybe see if it works, right? So first, I will start from the beginning until I will reach. So I will for element index value in enumerate as 2. Then if index less L1, I will just but you see, the I tend to create like internal structure that allows me to, I would do it like in real life project. If it is a real life project, I would add auxiliary structure that contains two counters, and every time I change, I will have add and remove procedure. And you know what? Let's do this. So let's call it class mapcom. We'll give it S1. And what we're gonna do, we're gonna assign, create first counter, right? Then we are gonna assign window counter. And we also have a method like add character, in which we, what we're gonna do, we're gonna get we're gonna get character from with 0. So we assigned value to it, and then we add window counter, we add we, and also we can say we do matches, right? So self matches equals 0. So if self C1 equal with character equal, we add self matches, we just add +1, right? Else do we have to decrease matches? I would do decrease matches because they are not equal. Every time we add, we decrease. And yeah, the same we have to remove. Pretty much the same. Except we decrease. And also we can say if window v equals 0, we just remove it from here, right? We delete window count. Else so also we can say if C not in self C1 keys, we increase. Oh, we don't have to increase matches. We have to do the same. We have to say if C1 is equal, we matches 1 plus 1, otherwise plus 2. And we can say def match. And if self matches equal whatever we have L1, yeah, like that. So this auxiliary structure could help us compare as we go compared to maps with ON complexity, right? Every time we have, it could be an error somewhere. I'm not sure what 100% that it will work, but yeah, as we go through this, so we create this compare map compare, and we pass S1 into it, right? Then as we go, if equal, we just add value to it. If it's equal or more, what we're gonna do, we're gonna say if compare match, we return true. Else, we So as we go, first we delete. So on 0 we just add, on 1 we just add, but 2 is not equal, is not less than 2, right? So now we compare, then we remove um, L minus L1 minus I character. So we call comparator. We call it comparator. I had a to add. I should have remove. So I will remove character from S2 L1 minus I minus L1, which is 0, will be 0, right? Then add I, which is next. And then at the end, we return false. All right. So this is the case. Yeah, I really like having auxiliary structure because it could be we could have tested it before. We can create unit tests to make sure that it's working, and then we can obviously self, and then we can reuse the same structure over and over because it's like common strategy to keep to compare on if to check if maps are the same, right? Window counter is not default again. So you can see here, it's returning true. Before returning true, I would print match. I will print match window counter. Oh, you know what? Let's add print function. So there is something wrong here, and I have to find the bug. But I will print, and here I will print self matches maybe. Then self window counter and self C1. And yeah, maybe self L1 as well. And here I will print yeah, let's copy this in underground. Obviously self uneven does it okay, uneven. Oh, come on. All right, so we have E and I 2. Okay, so we have counter. This is perfect. A B1. So we have matches. What, -1, -2? How -2 equal to 2? I don't know. Okay, so as we go, we get a counter and we add it to 1, and if window counter the same equal um, for character equal, we increase matches, then we decrease matches. So we can see C is not even here. So we can say it's perfect. We have like -2 here. So after we remove, we can say if C not in C1 keys, we can say matches uh, yep. All right. This one is looking very good. Let's try to submit it. Okay, so ACD, DCA false. So we we added D, we removed D, we have on CD, and then yeah, we return false because we were incapable of detecting same. So we have DC11. We have 2D because we added D. DCD. Okay. And we say that this is not a match, right? Then can I return maybe at the end? It could be corner case. Can I say like this? Yeah, it is corner case. All right, wrong answer. This is interesting. So we have ABC, and first we have 3B. Amount of matches is -1. Is this repeating thing? So this is ABC, right? So I have to have BC, but I don't have A. BCA, is it corner case again? You know what? I think it will be just call print instead in a match. I can do self print. Because I don't see what happening in corner case. Okay, let's try to submit again. BCA, ABC is the same, but I still have one matches. Why it's one? So I add B, I add B, I add B. And every time I add in B, I'm adding minus, minus. So there is something in when I add. So it says it matches only 2. So let's trace how it works. So we add in B, it's not match. We decrease in matches, right? No, it's 1 and it's also 1. So we add in +1 match. So we have matches 1. Then we add another one, B. Now we have it more than we have 2. So we have matches 0. Now we add another B and we have 3. And we have matches -2. Right? Now we're removing B. Removing B, 1B, right? So we okay, we have on 3 Bs. Now we go on C, and first thing we remove first B. And we add C. We remove first B. Okay. Let's run this example here through my code, maybe somewhere here. All right. So here let's have window counter in here as we go. So we have matches. As beginning number of matches we have 0. We add B. B is the one here, so we change matches to 1. We add another B. We have matches 0, B to B. We have third B. We have matches -1. We have B3. This is the question. See, do I have to do -1 matches? I think I have. Okay, let's go forward. And according to my code, we remove 1B. See, here is the thing. See, but I remove it's -1. So if when I add, I have to have two options, right? I have to say if character in self C1 keys. What, and then if it in, I have to compare. If not, I have to decrease character. And that should solve my problem. It's still not. See, this is mismatch. No. So B will be okay. B will be 3. So 0. We have 1 match. Then we have we have 0, and then we have -1. And B is 3. Then we go forward. BC. We added C. We have 0 match. have C match, and here we have B2. Then we move forward, we have B1 match, which is match C1 and A equal 2. So 2 not equal 3. A1, right? We have 3 matches. Why we have 2 match count? And the reason why we have 2 match count, because if we add like I should say, if C in cell C1 and like this, see, this is what I'm saying, it's 1, 3. So after we remove, we just check counter, and if counter is equal, we just increase, but we don't have to. Yeah. Okay, it's almost like 15 minutes. Let's ask ChatGPT for help. So let's say I'm trying to solve this guy. Trying to solve this guy, and here is my code. Why it's not working? Matches count habits. Okay, a remove is float when updating matches. Especially self-match should increase only when exact amount is reached and decrease only if match is lost. Okay, I agree. Non-existing character is wrong. If character is not, we should not update matches in remove. You remove in matches when character not in as one is removed. Yeah, I like it. So self character window we increase only if in window count. Okay, that's naturally. I didn't makes its count exactly increase matches. If C and self count equal, we increase. Else, if C in and okay, that's fancy. So we have two problems. Logic inside add remove is float, update match theory. If self match should increase, um, matches should check for both before and after adding and removing. Oh, that's interesting. So before adding, we check if we lost match. This is the whole thing. Okay. Yes. So we add. Was match, now it's one. Okay. Huh, this is very interesting. So it's not counting like match counting, but it was match, now we lost match. It's on remove, right? So on remove, we can say um, if um, but okay, matches, we lost match. Now, yeah, naturally, we decrease. And we delete. Okay, that thing is understandable. So we decrease. It is this guy. So self win counter, we decrease -1. Then if self window counter C is equal 1, we delete, right? And now that thing. So if they're equal, so we check in before and after every time. But why we need to check if C in C1? Oh, because we're checking it. Okay. Mm, let's see. 0, we may remove it completely. This is why we need to check, but we also check if C in self C1 and is equal, then we add matches. The same with add. We check in before If they're the same, we registering we lost match. I can say okay. I like this fancy thing. So if we say like this and equal v, then we lost match. Yeah, now I think now I understand the whole matching tracking logic. Like we have to check if we lost match. We decrease only if we lost match, not anytime we add stuff, right? But how about this thing? So and then if after we assign. Okay. All right, let's try it now. Oh, it's still brown. Why? So when adding thing, here I have to increase matches. Yep. Yay, we did it. Okay, yeah, let's remove printing. We don't need it. Yeah, it's very good. And I really like the structure. I believe the structure will be repeating in more. I see more tasks with the thing in it. So yeah, really good thing. I would practice on writing the structure over and over again and solving more and more tasks. And yeah, as after I tested it, I can reuse this class and use in more tasks. But it's really cool. Yeah, That will be it for today. Thank you for watching. Yeah, and feel free to join if you're if I'm on a stream and you join. Feel free to join, and maybe we do lit rooms sometimes. Yeah. All right. Thanks.